Hi everybody. So I had a request to see a couple of inverse trigonometric problems. So I wanted to do a couple. The first one is the problem, the integral of 5 over 1 plus 4x squared dx. Well, let me do a couple of things here. So the first thing that I do when I'm looking at one of these problems is I ask myself, what form is it close to? Well, it's close to the tangent inverse form. It doesn't need to be perfectly matched, but we can have some constants in some different spots, and we're going to learn how to manipulate to be able to get those in place. So I'm looking at trying to get it into something where we have 1 over 1 plus the argument squared. And this one here is something going on with, or right next to the argument. All right, so how do we deal with this one? So first of all, and let me go over here. I say, what is the issue? Where is the constant coming from, and why is it causing us trouble is what I was just trying to sum up right there. Handwriting's awful, but you see the issue here is that I have this 4, I also have this 5, but the 5 can reasonably be dealt with by pulling it out. But that 4 is a bit problematic because it says whatever's in this space has to be squared. Right now the 4 isn't squared, but we can make it squared. So what I'm going to do is I'm going to try and take this 4 and get it so it can sit with the x in the argument and be squared. So I make this 2x in the parentheses. In other words, it's the quantity 2 times x squared. So now we have an expression that's in the argument that's squared, and it matches that form almost, because we still have that constant or the coefficient to deal with. So what we do is we let u be equal to 2x, and then du will be equal to 2 dx. And then, solving, we get 1/2 du equals dx. So we'd already pulled out the 5 earlier, so that's still sitting in front. And I have this 1/2 du, so the 2 is going to tuck underneath. And now I replace the 2x that we had here with the u. And now we are in the form that we need it to be in. And so what I'm going to do now is I'm going to take the antiderivative and I'm going to have the tangent inverse. So at this spot right here, I have 5 over 2 tangent inverse u plus c. Now, u was equal to 2x, and so I put that in that place, and I have my result.